Welcome back, guys. Just to remind you, this is part 2 of chapter 2. If you have not watched part 1 of chapter 2, I would recommend you watch that before and come back to this. In this part of chapter 2, we will be talking about data types in C Sharp. So stay back and enjoy. In C Sharp, there are two types of data types, right? So one is a value type data type, another is a reference type data type, right? Now, value type data types now again are divided into two types of value type data types, and same applies for reference type. Both are divided into two categories. One is inbuilt or predefined. So by inbuilt and predefined, I mean the data types that the framework provides you already. You don't need to code for it. You can just use it, right? And you have custom or user defined data type. Same applies for reference types. You have inbuilt reference type variables and you have custom reference type variables. Now, the question is, what is data types in the first place? So data type is nothing but wherever you are storing data inside your program, you need to store it in a container, right? To store the data, you need to store it somewhere so that you can retrieve it and use it later on. Where you store it needs to be of a type. A very real life analogy for this you can think of is when you are trying to store a liquid, you will have a cup to store it. If you are trying to store some papers, you will have a file to store it, right? So the storage container or the storage place differs based on what you are trying to store inside it. Same applies here too. If you are trying to store a numeric value, we store it under a data type called integer. In C Sharp, we declare it as int. We don't write the whole integer. So similarly, we have double and float to store decimal point data. In user-defined value type data types, we have structures and enums. These are again different types of data types. We'll use those throughout our training, but for now, just remember their names. Reference types, there's something called string. So string is where you store sentences or words. Here in integer, you are storing numbers. In strings, you can store a sequence of characters. Like if you want to store your name, you can store it in a string type data type. And custom or user defined reference type data types are classes and interfaces. Classes we already saw. This is something where you can logically group your variables and methods, and we will talk more about that in this chapter. Now we keep talking about value type and reference type. What are these? Now let's move to that. Now as you can see here, imagine this green box is your apartment where there are multiple flats, right? People have addresses or apartment numbers for each of those apartments, right? Each of those flats have their own numbers. Similar is the structure of our computer's memory. It contains millions and billions of cells where you can store either the number 1 or 0 because everything talks in Boolean. So just to oversimplify that, I have made these small boxes to show how the data is stored. So here you can see when I'm declaring an integer type variable x and storing 5 to it, 5 is allocated into one box in the memory. And x actually points to that box. So whenever you're trying to get the data of x, it will go here and get the data out of it. So x contains the value that is being stored in x directly. You can directly access x and it will give you the value directly. However, a reference type variable, for example, if you have something called string, if you declare something like string s is equal to high, then what happens is this high gets stored here in a location, and the address of that location is stored in a location which s refers to. So now you saw I use the word refer. So when s needs to get the data back, it needs to go to where it is pointing. In this case is X003 location. There it will find the address of the house or apartment or cell in memory where the string is stored. So here it will go here and find that it's X005, and X005, it will go to X005 and find that the high is written there. That's how it will retrieve its value. So this is the difference between value type and reference type. Now let's move to the different data type sizes. This chart actually contains all the different memory size and how much memory space your different data types will take if you are initializing them. I would say for the sake of this particular training, you don't need to like memorize or go through each of these. You can pause the video here and see how much space it takes. This is mostly important when you are writing a big application. We should always make sure that we are using the minimum required size variable. For example, if you're only going to store roll number of students, an integer type variable will be more than enough for you. So what happens is you just use 4 bytes to store one roll number. However, if you store the same roll number in a long type variable, yes, you can store it, but you will be wasting a lot of bytes in memory. For small programs, which we'll be mostly doing in these videos, it doesn't really matter. But when you are building a big application, unnecessary memory allocation also matters. So the best practice is try to use the appropriate data type, what is actually needed by you. So the next topic I wanted to cover in data types is classes. So classes, as we discussed a few slides earlier, is a user-defined data type. You actually define what your classes will have. So it's a reference type data type, and it's a user-defined data type. Under that, we have classes. A class is a collection of properties and functions. Now, what are properties? Think properties as description of the class. For example, if someone tries to describe you, the properties that he will talk about you are maybe your height, your eye color, your hair color, your skin color, etc., etc. So those are your properties. Those describe you. So these properties are something that describes the class. Similarly, we have functions. Functions are nothing but actions. Functions are verbs. So similarly, functions are actions of that class. These are actions that the class can perform. Now let's get to an example to clear it further. So suppose we have a class called vehicle. Now vehicle can have many properties like engine capacity, number of wheels, color of the vehicle, and so on and so forth. So these all comprise of its properties, which can differ from car to car, vehicle to vehicle. It also has some functions like it can run, it can start, and it can honk. So this is what a class is all about. A class is a collection of properties, functions. Properties are descriptions and functions are actions. Now, what is the benefit of putting all these properties and functions inside a class? Why can't we have these directly inside my program, like in structured programming languages? So here are the benefits. One, your code is now encapsulated within a class. It's not spread everywhere in your program file. Number two, it encourages reusability of code. So suppose if you build a vehicle class today and tomorrow you need the same vehicle class in some other program, you can just pick up the class. So the third advantage is if you put all of these inside a class, it gives you a feature of access modifiers. What access modifiers means, you can actually mention in your code which property or which function can be accessed by whom. If you keep the variables out in your program, anyone can access that. So that's a huge advantage of object-oriented programming language. Now, fourth advantage of putting these inside a class is suppose you made a vehicle class and you borrowed that class to your friend. Now, your friend can extend that class. That feature is called inheritance, where you can inherit from a class without knowing what is the implementation. So your friend may add two additional methods in this vehicle class, say go reverse, be one function. He doesn't need to really write code for start, run, and honk. He can reuse the code that you have already written and he can add upon it. Now, with some good understanding of what classes are, let's talk about some of the features of classes. First, we will talk about constructors. Let's go back to Visual Studio and do some coding. So this is our first Hello World application. What I will do now, I will create a vehicle class inside it. So I will right click, add, new item, or class directly. Class is by default selected. I will give a name to the class and I will call it vehicle. And I will click on add. What will happen is there will be a vehicle.cs file that will be created. If you click on that file, you will see there's a class created for it. Now, how do we use this class? The moment the vehicle class is created, you can go back to your program.cs. Here, what you can do is you can create a variable of type of your class. So your class name is vehicle. So that's our class. I will define a variable where we can store a reference of this class. To create the class, we will have to use the new keyword, which instantiates or allocates memory like we just saw for this particular data type. Now this vehicle variable or vehicle class has no methods defined into it. Neither it has any properties. So let's go and add some. Let me add a property called color. So the data type of that property is string. The name of the property is color. And I can get it and I can set it. So this is how we define that what is the name of the property and what can be done on it. So I'm saying that this property can be get, someone can get the value of it, and someone can set the value of it. It's a good convention to name the properties in uppercase. Now, let's go back to our program. Here, now if I write vehicle and put a dot, I can't see the property that I just created here. The reason being, I have not made this property public. This is what I was saying by access specifier. Let me make it public now. The moment I do this and go back here, now you see we have the property accessible here. This wrench symbol identifies that this is a property. So I can set the property to red because color is a variable of type string. So if you hover over the property, it will tell you the data type and what you can do, get and set, right? However, this class is not really useful so far. It can get and set, but it cannot do anything. So let me go back to my vehicle class and add a method here. I will call this public void. The void keyword here tells you that this method is not going to return you anything. It will just print something. Like I said, if you have done a programming language before, like C or any other language, you might have encountered this there too. So name of the function that I'm going to write is print details. So this will do nothing but printing the details of this particular class object. So what it will print here is the color. So I will use the same way, console dot write line. Here I will print the color. So I can directly access color and put a semicolon. To make it a little bit more user friendly, what I will do here is color of vehicle is. So this will do nothing but add a statement in front of it so that you know what this color is about. Now let's go back. This is my class. Now I set it to red. Here, what I will do now is vehicle dot print details. Now this is where I'm calling that method. For testing this, I will just comment out these two lines. So this is how you comment in C#, just 2 slashes, and it will be commented. Now here you can see my program is ready. I'm creating an object of type vehicle. I'm setting it to color red and printing the details of it. And I'm waiting on screen to read a key. Now let's run the program. Here it goes. So here you see I was able to successfully print the color of the vehicle using the function called print details. Cool, right? We started this discussion about constructors. So here if you see, I have called something that looks like a function call, right? Vehicle, then opening and closing braces. Looks like a function call. But if you come to vehicle, there is no function which is named same as the class. So this is called a constructor. Like a program has an entry point called a main, every class has an entry point as well. That is called a constructor. Now every time you are instantiating this object, this is the first method that gets called. Now here in vehicle class, I don't see that method. The framework by default provides you with a default constructor. This is called a default constructor. The constructor without any arguments is called a default constructor. That default constructor is provided by default to you, and you don't need to define it specifically in your class. However, no one stops you from defining it. A shortcut to create constructor is CTOR tab tab. That will give you the constructor. Now this is the constructor. So what will happen here when my program starts executing and this line is executed? The control will go to this particular method. So here what you can do is you can write code which you want to execute before an instance of your vehicle is created. Now let me give you an example. What could be one of those situations where you will be using this? Here we are setting the color and printing it. In my program, I will just close this out for now. In my program here, you can see I'm setting this to red. What if I don't set it to red? Right? By default, the default value of a string is an empty string. So color will have no value in it because you have not set it. So if I run the program now, you will see it will print. The color of the vehicle is empty. It didn't print anything. What if I want to do something like this? If someone has set the color of the vehicle, then it's fine. If someone has not set it, I will by default set it to not set. Okay, so let me write this. Color equal to not set by user. Okay, so whenever now the instance of the vehicle class is created, it will first run this statement and then any subsequent statements that you are writing on top of it. So here if I don't set this color to red, previously it was showing as blank. Now I have set it in constructor as not set. So now if I run it, I will see it is showing as not set by user. Color of the vehicle is not set by user. However, if I go ahead and set it, it will stop showing that and instead show the color which I have set. That remains same. Okay, now it starts showing red. Now that was the default constructor. Now we can have more than one constructors as well. You can have another constructor, CTOR tab tab, and add parameters to it, right? So here, what if I want to take the color when I'm creating the object itself or creating the instance of vehicle. You can pass an argument to a function or a constructor like this. You need to give the data type and the variable in which the argument will come to you. Here what I'm doing is I'm setting this color to this color, right? So this color gets set to the color which you are passing here. Now let's see how we can use this. Here, instead of setting the color as a different statement, now what I can do is I can pass the color here itself. Let me call it green so that we know it's coming from here. Okay. Now when we run this, you will see the color is set to green. Let me go ahead and create another vehicle object just to prove the point. This is vehicle new, vehicle new dot print details. Here I will not pass the color and I will call our old default constructor. Okay. Now if we run this, first one will be vehicle, second one will be vehicle new. First one is set to green, second one is marked to not set by user because you have not set the color in vehicle new, neither you have passed it in the constructor when you created it, right? So that's how you can use constructors to run piece of code that you want to execute when you are starting the class or when the class is getting instantiated. So one important thing to remember regarding constructors. This is a constructor and you may skip it if you don't want to execute anything when the class is getting instantiated. If that happens, then the compiler or the runtime environment will provide a constructor for you. But here, once you define a constructor by yourself, C# will stop providing that default constructor support to you. Okay, it will not automatically provide a constructor for you. Here, I have provided a custom constructor where I'm passing this variable. Now, this statement will stop working because now compiler is not going to give you that default constructor by itself. It is assuming that since you have written a constructor, you know what is best fit for your program and you don't want that anymore. Okay, so always remember that if you are providing a constructor which is a parameterized constructor, you lose the default constructor by default. If you still need it, you can get it back by putting it yourself explicitly. It will not be provided to you by C# anymore. Okay, now that we have dealt with constructors, so now let's talk about access modifiers. So the access modifiers, which you can see here, public in both these places, defines that who can access this, which all components of the program or class or other classes can access this property or can access this method. Public means everyone can access this. So that's why from within program, which is a different class, we can access vehicle's color property. If I go ahead and make it private, this will start throwing me an error saying that vehicle.color is inaccessible due to its protection level. If it is private, the only code that can access this color is this class. So here I can access color because it belongs to the same class I am in. So private means you can only access within the class. So the next access modifier is protected. What protected means is that this can be accessed from within the class or any other class that inherits from this class. We have not reached till inheritance yet, so we will wait for that. So there is another access modifier called internal. So what internal does is it identifies that this particular property can be accessed by any other class, including child classes, of course, if they belong to the same assembly. By assembly, I mean it needs to be under the same project. But you cannot access this from here because this assembly is different. So that is internal. There are a couple more which I will put it in the description. There's a very good page in MSDN or Microsoft's documentation which talks about all these types. The other two which I'm not covering because they might not be used by us in these classes, so is protected internal and private protected. You can just read through it. These are a combination of these two, so it will be easy to understand. Now let's move to instantiation of an object. As part of constructors, we understood how classes are instantiated. You use the new keyword and the class gets created. So the new keyword actually creates a space in the computer's memory where your class is set. And we know that classes are reference type variables. Now let me show you how the memory allocation actually works. If I write the statement vehicle v1 is equal to new vehicle with color as black, I'm using the parameterized constructor we just created. Now, if I try to print the details, let's see what it prints. Yes, the color of the vehicle is black as expected. When this happens, this is what happens in the memory. You have this variable v1 created. Inside that you create a vehicle. Since you pass the parameter as black, it created a vehicle which is black in color and stored to a memory location. And since it's a reference type variable, it stored the reference of that memory location into another memory location and called it v1. So v1 gets created here. It stores a reference of the memory location from where your vehicle is actually stored. Now let's go back to our code and write this line. I'm creating another vehicle type reference variable and setting it to v1. In this case, what happens is, so now we have v2 which has the value of v1. Here v2 gets a memory allocation of its own which is different to v1. Since we have set v2 equal to v1, what it does is it copies the reference to here. Now essentially v1 and v2 are pointing to the same vehicle which you had created here. So now I try to set the color of v2 to red and try to print v2's details. So since I have set v2 to red, very good, it will be red. We printed v1's detail first, so it's black, and then I set v2 to red, so it's red. Now what happens at this point if I try to print the details of v1 again? So as you can see, once the program runs, you will see the first print details of v1 is black. Then the subsequent v2's detail is red. However, when we are trying to print the detail of v1, that is also red. Going back to the diagram here, so as you can see, since v1 and v2 are referencing to the same vehicle, when you set v2.color.red, it actually ended up setting the color of the same vehicle as red. Now v1 and v2 are both pointing to a vehicle which is basically the same vehicle and is red in color. That is why when we are trying to print details of v1 after v2 setting it to red, we are seeing red in both the instances. Now this behavior would have been very different if we were dealing with value type variables. Let's see how. So I start with writing these two lines of code. The first line declares a integer type variable and also sets it to the value 1. Now here, since the data type is integer, x is having a data type which is of value type. Now next I just print the value of x on screen. Let me start with this. And here is the output. X is equal to 1. Now I move on and add these two lines of code. Here what I'm doing is, like we did in the reference type example, I'm setting y equal to x, where y is again of type integer, and I'm setting the value of x to y. If you remember our previous example, that was exactly what we were doing in this line up here. Then we print the value of y here. So as you can see, value of x equal to 1 y is also 1. So far, it's very similar to what had happened in our reference type example. Now let's go and check what is happening in the memory. When we say int x equal to 1, it creates a memory location, assigns it to x, and sets the value 1 to it. Next, we wrote int y equal to x. Now, since this is not a reference type variable, unlike what happened last time when we said v2 equal to v1, it had the same reference. Y got its own memory location and copied the value. This is a value type, right? So it copied the value of x to itself. So this is a value copy, not a reference copy like last time. Now let's go back to our code and now set y equal to 5. And then let's try to print both x and y and see what happens. So print x, print y, and run it. So as you can see here, x was 1, y was also 1 from these two. Then we set y to 5, and now we are printing x and y in the last two print statements. So x is still 1 and y is 5. If you see, when this happened and after that you set y to 5, since y is not a reference type, it just replaced its value to 5. So x and y are totally different and unrelated, unlike the last example where changing of v2's color actually changed the color of v1 because they were essentially the same object reference for both these variable types. That was a discussion on how the runtime handles memory allocation of reference type variables and value type variables. I just want to reiterate here, guys, this is extremely important that you understand how reference type variable allocation of memory differs from value type variables allocation of memory. This will help you to understand where your data is getting resided and how you can access that. And if you understand the difference, you will avoid a lot of bugs in your code where you might assign something or change something in a reference type variable thinking that you are changing a different variable, but you are actually changing the actual referenced object in memory. So please try to reflect and understand the difference between these two, and that will help you on the long term. Now in part 3 of chapter 2, in the next video, we will move on to some common library methods and some basic debug features that Visual Studio provides for you when you are building your program. So guys, don't forget to watch the part 3 of chapter 2. If that video is not already uploaded, it will be there in next couple of days. Thank you for watching, and don't forget to subscribe to my channel, like the video, and share it with your friends. Until next time, goodbye.